to overcome them. So this is just a quick introduction. I'm a knowledge entrepreneur with gold medal in electronics and communication engineering with about 32 years of work specialization in business administration, sales and marketing, bachelor's degree in and master's degree in tourism and travel. And I am a lifelong learner. My key strengths are to work in the new and emerging technologies and help businesses to adopt the same for real benefits. I manage a company called SPH Consultancy and E-Services and also manage two projects called Smart Edge and Divas for Business to help youth and women to adopt technology for learning and business development. I have been recognized by many awards from Goldman Sachs, MasterCard, USABF, and been consultant to many award-winning projects. Some of them are MP Treasury and Senate, which won e-governance awards. I'm an avid Twitterati and more than 69,000 tweets now. And I use that as a medium to share knowledge through 10 odd Twitter posts that I do every day. My Twitter handle is Bhasin and Bhasin, and my LinkedIn profile is also Dolly Bhasin in the LinkedIn. So just to begin with, I'd just like to set the context by saying that there is a rise in artificial intelligence and AI is set to permeate all areas of our lives over the next 3 to 5 years, from customer services to financial advice to recruitment and medical diagnosis. In fact, the customer service by 2025 will be 95% of all the customer interactions will be driven by AI, whether it is online chats or whether it is through phone. Or through chatbots. So in sales, 30% of all the business-to-business companies will employ AI, and at least as one of the main primary sales process by 2020, as per Gartner's report in 2016. 85% of the data and analytics of European countries are on track to use AI and business analytics by 2020, as per Adobe. Undoubtedly, the rise of AI will improve our lives in many respects, but it also presents serious risks. AI relies on algorithms which learn from real-world data, so it can inadvertently reinforce existing social biases. Gartner predicts that by 2022, 85% of all AI projects will deliver erroneous outcomes due to bias in data, algorithms, or the teams responsible for managing them. So it is basically that we have to really do a lot of work to understand what are the kind of biases and how these biases creep into. In particular, today I am going to talk about the gender bias, how it comes up and how it manifests itself, as well as what is everybody doing around it. So the issue is not only AI, but also how the human build AI. There is a very real risk. Instead of solving the problem of gender bias, AI will only enhance it further. Already today, we see targeted ads where algorithms are perpetuating and the pay gap by targeting listing for better paid jobs towards men. Women are slowly getting out of the job market increasingly in the developed countries, and also the trend is showing in the current Indian scenario also. Meanwhile, virtual assistants, which are supplement of the unpaid work, tend to be portrayed by women, and many more women than men are predicted to lose their jobs by the automation through chatbots. And this is a very, very alarming reason, because most of the chatbots are being named as women in terms of whether it is a chatbot for Amazon, or whether it is a chatbot for any other company, names are, there is a bias which is towards naming them as a woman. And consecutively, the woman per se, the jobs are actually kind of going out to the voice or the chatbot rather than being to the woman herself. Now, the misconception is that AI is objective and it should rely on mathematical computation, and so the construction of AI system is, but the construction of the AI system is inherently human-driven process. It is unavoidable that such systems will contain bias, and we will discuss today a little more in depth what is let's first understand the problem. The expected results in using AI, if AI is a highly structured machine language, there's machine learning. So we expect that hiring by algorithm would give men and women equal chance at work, because they are more or less 50-50% of the total population. So the work also should be divided 50-50%. Voice and speech recognition will also have similar results for both men and women. Face recognition should also have similar errors in both women as well as men, and produce accurate results in health-related and criminal justice arena. Search engines should produce searches based on the words given and not based on the gender. But unfortunately, it doesn't happen the way. In actual practice, there is a gender bias. Several researchers have found that voice and speech recognition systems perform worse for women than for men. I'm just leaving the link here for people to understand and read more about this. Face recognition systems have also been found to provide more errors with female faces as compared to male faces. It also has a particular this thing that the women who are black or who are dark colored face the major brunt of the system. Recruiting tools based on text mining also inherited the gender bias from the data that they train on. Search engines widely used by citizens can also reflect gender biases. For example, if we look for work or go shopping in image search engine, we might find more men photos for the former and more female photos for the latter, reflecting our society's stereotypes present in data and annotations. In terms of gender bias, it's also very relevant and also in sensitive applications such as health-related or criminal justice-related areas where we actually have a huge amount of gender bias, and that is alarming. So let's look at a little more deeply what the gender bias and how it is affecting AI. Out of the 5 examples, I'd go through 3 examples a little more in detail to really analyze what really goes behind and then what we can do to really address them. So I'll look at the recruitment system, I'll look at the facial recognition system and search engines for search and translation. So hiring managers at Amazon, for instance, had very high hope about using AI-powered recruiting engine, which they had developed in-house over several years. So everybody wanted that this will be the holy grail and we will have no recruiting problems with AI-driven system. They literally wanted to have the engine to give 100 resumes and it will split the top 5 and then come out with top 5 people who can be recruited or who can be hired. The project actually backfired. Amazon soon discovered that its machine learning models were introducing bias and favoring male candidates because it had been trained on male-dominated piles of resumes submitted to the company over 10 years period. To add to it, the whole the staff that was developing the AI model also were predominantly male. So the female representation was very poor in terms of the actual AI algorithms that were built. Gender wasn't the only aspect of the bias. Errant data led to algorithms to advance many unqualified applications, and Amazon had to ultimately scrap the entire effort. So this was a very big learning for a lot of people, especially the large companies, the way they were really wanting to go in for AI-based hiring process. And towards the later part of the slide, I'll just show you what the world is now doing to really correct some of this. So the other area is a facial recognition problem. Most automated facial recognitions are type of facial analysis technology and not true facial recognition. Facial analysis technologies as any kind of technology that analyzes human faces. Facial analysis can spot faces in videos or images and assign generic attributes such as wearing glasses. Recognition is, however, very different technique by which the individual face is matched to faces in the video and the images. Before AI tools are used to determine the identity of the face or expression of the individual in the video or image, a face must first be detected. Without this basic step, you cannot proceed further. The facial detection system have repeatedly been shown to fail on faces of dark-skinned individuals. Assuming a face is detected in the first place, AI tools can then be applied to guess emotional attributes based on expression of the face or demographic attributes about the face like gender, ethnicity, or age. So, but however, when Facebook announced that it has achieved 97% accuracy and to set a gold standard benchmark of the day called labeled faces in the wild, when researchers took a closer look to this gold standard, they found that the data set was about 77% male and contained over 80% white individuals. So there was an inherent bias which really crept into this data set. Consequently, you had a huge bias towards males and males also white males, and a large gender bias when it was used by any of the AI application. So to solve this problem, Joe, one of the MIT researchers who did her master's in thesis on gender shades, actually studied this particular problem in more depth. And the results are available at the Gender Shades site as well as gendershades.org, that is. And also it's available through a video which is available on the link which is given here. The entire paradigm was to really look at data which is uniformly from the European countries as well as the African countries to get a good mix of both the dark-skinned as well as the white-skinned people. And this is basically the data from the people who were in the parliament of the countries. So 3 countries from each area, and both male and female equal representation was made. And this was a very landmark study which has actually showed that the probability of having the dark-skinned female errors is much higher, and the white males is much lower, in fact almost up to 100% results. So there are a lot of work which is at the leading tech companies, what they were doing, like IBM, Microsoft, and Faces++, and performed a whole set of AI algorithms around the various types and genders. And in all the systems, she found that the male faces performed much better in terms of accuracy over the female faces, the detection that is. And the lighter skinned faces in all cases worked much better with the darker skinned faces in overall. So error rates were pretty high in terms of 35% for darker skinned women and 12% for darker skinned men, whereas 7% for lighter skinned women and no more than 1% for lighter skinned men. So on an average, what we can say is that she was able to really get a much betterment in terms of her data set. So what we could understand from her research is that the data set, how the data set is managed, is a very crucial aspect of understanding gender bias in the system. And also how you really treat the, how do you develop the algorithm based on, so her rating of this thing was, while the IBM and Microsoft had much better accuracy, Face++ had a much poorer representation in terms of the algorithm. And that was probably because of the data set that and the kind of algorithm which was developed, which has the inherent bias into the system. Now let's look at how the gender bias is happening in the language learning. In terms of when we really look at any kind of language that is used in the search engines or translation or any kind of such applications, whether it is by Google or Siri or any other discipline, female names are generally associated with the family names, whereas male names are associated with carrier terms and demonstrates how AI perpetuates gender stereotype using Google Translate. So for example, in Turkish language, there are 3 pronouns, he, she, and it. So if you use a gender neutral pronoun in the pair of sentence, like it is a doctor or it is a nurse, typed in Turkish and ask for translation in English, what will happen is Google will show a result, he is a doctor, she is a nurse. Despite the fact that the text was gender neutral, which was given for translation from Turkish to English, but when it comes to the English version, a stereotyped representation of a doctor being a he and a nurse being a she. So these are the kind of forms of gender bias that exist today. I have not gone into all the biases. I have just gone into just give a representative sample because the time doesn't permit to go in deep into any of the other areas which involves a whole lot of explanation in terms of their sector specific constructs. So let us understand a little more in depth what is a bias in the first place. Bias is believing that some ideas or people are better than others. They could be explicit bias or they could be implicit bias. They could be unconscious bias or conscious bias. That is, you could actually have a deliberate held belief about a person or a group, which is a conscious bias. So, for example, in India, people who come from certain parts of the country which are backward areas like Bihar, so, they are considered to be less educated as compared to the others. So this is a conscious bias. Whereas in implicit bias, beliefs about others or ideas outside of our conscious awareness are called the unconscious bias, where you might not really know why it is happening, but it is in the back of our mind that, so as in the previous example, a nurse is unconsciously kind of stereotyped as being a woman. because 90%, the data shows that more than 90% of the nurses are female. There is also a confirmation bias, which is basically it seeks information to confirm our beliefs. So we would not go into detail of the confirmation bias. We restrict ourselves to the unconscious bias and really go a little deep, dig a little deeper at how this is contributing towards the uh, gender bias in our systems in artificial intelligence. Biases or prejudice that we have are unaware of mental shortcuts based on social norms and stereotypes. They are automatically triggered by our brains making quick judgment and assessments of people and situations as influenced by our background, by our cultural environment and personal experiences. So who has these biases? These biases are available to everybody, including individuals who are explicitly believe that prejudice and discrimination are wrong. They are quite universal in nature. Almost everybody has some amount of bias in the. So let's see one example. Now you must be seeing on your screen some text which is written in different colors. Now, the moment I ask you to really please state the color of the text, I'm sure after the first line, the second line you are going to speak the wrong color of the text. And the reason is that the text is actually colored in a different color than what is written on that text. So this is unconscious bias, where you are programmed to really read out what is written rather than actually speaking the color of the what is written. So so let's dig a little deeper and understand how the bias works in AI. So essentially bias, when people say that in AI the model is biased, what they usually mean is that model is performing badly. So it's not really representing the real environment or the real scenario. But ironically, poor model performance is often caused by the actual bias in data or algorithm. It's not by the model, but more on data and algorithm. And let's see how it works. So machine learning algorithms do precisely what they are taught to do, and only as good as the mathematical construction and the data that they are trained on. Algorithms are biased will end up doing things that reflect that bias. To an extent that we humans build algorithms and train them, human-sourced bias will inevitably creep into AI models. Fortunately, bias in every sense of the word as it relates to machine learning is well understood. It can be corrected, and there are methods to really correct the method. What we need to do is to understand the nature and how to deal with them effectively. So let's go dig a little more deeper. The umbrella term AI encompasses multiple subfields of machine learning, a field of computer science that, to quote Carnegie Mellon professor Tom Mitchell, studies computer systems and automatically improves with experience. The most common machine learning system in production today are classified systems and use a technique called supervised learning. In a nutshell, supervised learning systems infer mathematical functions like y is equal to mx plus b that represents some kind of relationship between the data as well as.
Excuse me, Dolly, I would like to ask a question.
Yeah.
So question is, just because a system is not recognizing a female's face over a male's face,
Yeah.
how could that be called as a bias?
how could a male face, so for example, there is it's not the question of male face, or there could be misrepresentation of that person in Vogue. So for example, if you want to really search for suitable candidates for a particular interview, you are actually being shown a data which is only male. You are not showing the female this thing. So there is a unconscious bias that really creeps in that kind of scenario. At the same time, there could be a different scenario altogether, like for example in the nurse case, where unconsciously anything, the moment you say nurse, it is assumed that it is a female nurse, not a male nurse. So this is the unconscious bias that I've been referring to.
Okay.
Is that clear?
Right.
Okay. So what where was I? I was in supervised learning system, which basically works around trying to really find a mathematical equation how the data exists between the data and the there's some relationship between the data that you are having. In supervised learning, data scientists start with a set of examples that exhibit an accurate relationship between data points, train a function that does a decent job representing that relationship, and then use this function to make educated guesses about new or unseen data. These systems perform better when data that they classify have distinguishing characteristics. It's hard to bucket things into categories when there's too much of similarity or too much of difference. And that is where another kind of bias comes into picture. So biases can creep into these supervised machine learning systems in three major ways. The first happens when the minority population is poorly represented. So this is the more detailed answer to your question, if Vishal. The first, as I said, the minority population, when it is poorly represented in the data set to train the algorithm. The example in terms of approaching fairness, for example, if a luxury hotel wants to offer a promotion to wealthy white people and a subset of less affluent black people, because they assume, the bias is that there are very less likely to visit that hotel, and the unconscious bias is exhibited, which actually does not allow the data set to really have too many black people in the whole process, just because the unconscious bias is that they are not very wealthy to really come and visit the hotel. The second reason for bias in AI systems happens when the features in data are closely correlated to one another, making it impossible to overcome bias by simply removing information like gender or race from the equation. Let's say, for example, there is a bank who's evaluating the risk of offering loan. To protect against racial and gender bias, the bank scientists decide to exclude columns in the database with information about race and gender. Now, suddenly you will have, all things equal, the race and the particular data is removed from the listing because they look very similar. So this also contributes to a lot of bias when you deliberately kind of reduce some of the vital data sets from the vital data from the data columns from the data set that you have. The third type of bias occurs when you are encoding into the training data itself. So in the supervised learning, algorithms learn by iterating variations of mathematical function until it does a good enough job to represent the relationship between the data. If your human judgment is based on a certain unconscious bias, then your whole premise of the algorithm that you're going to develop is going to be biased. So let's look at little more detail into different kinds of bias. So you have sample bias. The sample bias is a problem with training of the data. It occurs when data used to train your model does not accurately represent the environment that the model will actually operate upon. So there is a big science to choose the subset of the universe that is both large enough as well as representative enough to represent the mitigate the sample bias. So, for example, if we all understand or know about the autonomous cars, if autonomous cars were trained only during the daytime and you have no data on the nighttime, in the nighttime, the system will actually have a lot of errors, and the accuracy levels of the this thing will decrease, be very high. Uh, the errors will be very high. So this is something which could easily be solved by having the data set for both the daytime as well as the nighttime data. Now these are sampling techniques which need to be really understood before training the model, and it's most vital in terms of when you look at things which have unconscious bias, uh, which might be there, and gender becomes one of them. In terms of prejudice bias, it's a result of training data that is influenced by culture or other stereotypes. So you might have a prejudice against somebody or some particular caste or some particular religion or some kind of mental stereotypes which people have. For example, if we have a computer vision algorithm that is being trained to understand people at work, the algorithm is exposed to thousands of training data images, many of which show men writing code and women in kitchen. So you associate as a prejudice that the men are the one who will be working and the woman would be in kitchen. And this is basically because the data set that is available of images of people at work, uh, which are available in the current systems are on which the system has been trained, is having more of these kind of stereotypes. The algorithm is likely to understand that coders are men and homemakers are women. This is a prejudice bias because women obviously can code and men can also cook. The issue here is that the training data decision consciously or unconsciously reflected the social stereotypes. This is very true in the Indian context, very true in the context of women at work, and this kind of prejudices really bring in a lot of gender-based biases in the developed artificial intelligence systems, if not taken care properly. So let's move on to the third kind of bias, which is the measurement bias, which is basically a systematic value distortion happens when there is an issue with the device used to observe or measure. This is a kind of bias which tends to skew the data in a particular direction. So for example, if you are actually shooting with a camera which has a colored lens, so the entire imagery that you're getting is actually kind of tinted with that particular color of the lens that you have used. So the data itself has some kind of measurement error, which is going to reflect in the total data model that you really see in the actually in operation. This problem, this kind of bias can be avoided simply by collecting more data as well as avoiding using multiple measuring devices and the humans to train on and compare the output of these two devices. So there is a technique which is being used, which actually has two set of people really defining the model and the measurements of the data that is being done in two different people and then combining them and seeing the totality. So the effect of one cancels the other, it's assumed. So the fourth kind of bias is the algorithm bias, which has nothing to do with the data, but it it's a reminder that bias is overloaded. In machine learning, bias is a mathematical property of the algorithm. The counterpart to bias in context is the variance. In terms of so when we really look at models, we look at what is the kind of variance in which the training data is a model. I think it's getting a little more complicated, but in very simple terms, if I can say that if data is too close, that means there is very little difference between the data elements, and or if it's just too high a data, then there are certain assumptions that the system makes, and that is where it leads to a kind of the final algorithm that gets developed really is not accurate to the thing. So there's a good balance between what kind of data set that you should use, and this is an extremely relevant this thing where data scientists really come into picture in terms of really giving a very good understanding of the data, which means that there has to be a domain expert which is involved in terms of defining the algorithm, and not just the people. Anybody could really kind of define what data is to be used and what kind of algorithm has to be developed, what kind of model has to be developed. So let's look at how people are addressing the issues of gender bias in AI, and how we can improve the general quality of AI-based uh, gender bias. So Quicksilver is an AI-based software tool by San Francisco startup called Primer, which is designed to help Wikipedia editors fill in the blind spots in crowdsourced Wikipedia, the world's fifth most visited website, which has a long-running problem with the gender bias. So consciously, it just happened that one of the female researchers won the top-notch award, but Wikipedia page had very little information on her, and whatever information was there after the award was given, it was literally kind of the editor who had edited it actually kind of thought probably what I have written is wrong, and actually took that page down. So that's the kind of this thing that Wikipedia, it was an alarming kind of scenario to represent the gender bias in using the AI algorithm. And this was a combination of both Wikipedia's AI algorithm as well as the person who was the editor for that. So there was a very ambitious project run by Wikimedia, which is the Wikimedia Foundation, which came up with a new set of rules, especially to really develop a very conscious database of articles on women in the STEM area. And Quicksilver was the product that was used, where machine learning algorithm, incidentally, it's an AI-based product to solve a problem which actually got generated based on the AI problem. Now, what is being done in this particular case is that the Quicksilver uses machine learning algorithms to mine news articles and scientific citations to obtain notable scientists missing from Wikipedia. And then they write fully sourced draft entries for them. There are 40,000 plus summaries which have been inserted into the Wikipedia consciously through this automated algorithms. And now there is a conscious effort that at least 100 or more samples are added every day. So this is a very conscious effort by people, the founder of Wikipedia, to really make Wikipedia more gender neutral, especially to remove the biases which have inadvertently come up in the Wikipedia. So how are people solving the gender bias in hiring? There are few tools which have really come up, which are There are tools like Maya, which uses machine learning algorithms to screen resumes, schedule and conduct interviews, notify candidates, and other opportunities based on the skills and guide them through the steps. Now, there are some early adopter companies which have seen some good results. Now, this is basically the bias itself is being removed with AI, the application of AI, by correcting either the model or correcting the data set or correcting the prejudices which are there. So the other tools which are following suite are Beamery, Hired Score, Emroads, and Render, and they're all targeted towards different kind of data sets and giving a pretty good results, especially with the gender parity. So IBM was badly shaken once when the MIT researcher Joy had actually shown that there is a huge discrepancy between the data sets and how IBM handles the gender bias. And there was a very conscious effort to develop a complete AI fairness 360 toolkit, which not only looks at the gender parity, but also the other biases, addresses all the other biases in terms of a complete library of novel algorithms, codes, and tutorials. Now, this is something which is now available and open source and available on GitHub. These AI-based detection tools are available freely in the public domain. Now, there is another effort which is being done to de-bias, to solve the bias in the word association. For example, I mean, when we talk about certain words are associated with the gender. For example, there was I had just given an example of the nurse as well as the coders. Now, these are biases which are of different nature, but they are biases which are formed because of the kind of word association. Sometimes we see that the word which is associated, so when we create a model in AI, we actually associate it to a certain kind of this thing and create those data sets in that kind of manner. So for example, if swing and carpentry. Now, these are kind of analogies which are he and she kind of. So she and he. That is, swing is associated with woman and carpentry is associated with the man. Nurse, surgeon, blonde, burly, giggle, chuckle. So these are kind of analogies which were unconsciously the bias based on some prejudice or based on human behavior or the kind of this thing was coming into the language. And that was getting reflected in every search engine algorithm, or when the algorithm which was throwing up results in the window, it was actually associating carpentry jobs with men and swing jobs with women. So to do this, to remove this kind of bias, Microsoft Research published a paper to forcibly remove these biases from the language model and created a machine learning algorithm. Again, this research is also now freely available and can be used by anybody who is developing a AI-based model. Coming back to our chat, this thing, there is a lot of work which is happening in terms of really making the chat bot as gender neutral. And researchers and campaigners have designed gender neutral voice for use in virtual assistants to promote inclusivity in voice technology and help end the gender bias. Built by creative agency Virtue, Copenhagen Hagen Pride and Equality campaign organization called Equal AI. The voice is designed to reflect the growing number of people who define themselves gender neutral. So the product is called Q, and it's supported by major platforms which use voice technology in virtual assistants, including Apple, Amazon, and Google. This neutral voice has no pre-assigned gender, and the aim is to get the attention of the leading technological companies that work with AI to ensure gender bias is avoided in developing the AI devices. Because not only we are talking about AI-based models, we are now actually having AI really get more and more pervasive into various things, including high profile robots doing surgeries and so on and so forth. And if not corrected, this might lead to very serious repercussions. Last but not least, the real issue that has been overlooked for a lot of years is that not only is the gender bias because of some of the inherent things that we discussed, but it is because there is a very poor representation of women in technology. And this is one alarming fact which basically warrants that we need to improve the gender diversity in the people who are actually working in the AI domain. So first of its kind effort called AI Watch has been established by the European Commission to monitor the advancements, uptakes, and impact of AI in Europe. And there is a very conscious effort to really bring in more and more women in AI, both from as a technology developer community as well as the user community, so that the data set includes more and more women and these biases are removed. So this is what is the crux of what I had to say, and I'd be open to any questions if there are any. Vishal?
So, attendees, please send questions through the question or chat panel. Dolly has finished her presentation. We are here for another 10 minutes. We'll be free to respond to any questions you may have. Dolly, would you like to show your contact details in case people want to connect with you?
Yeah. So I had made one slide, which is the beginning slide, which has my contact details as well as my brief profile. So here you go.
Okay. So, any questions, please? Yes, some have started coming in. Well, this webinar is being recorded and will be made live on our Selstrat YouTube channel. I'll just post the link if you would like to access that. Otherwise, on Selstrat on YouTube, if you search for Disrupt 4.0, you will be able to get, or Selstrat, if you search, you will be able to get the channel. So this is a link that I have sent. It's for YouTube channel. It will be uploaded in a day or two. Any other questions? So we have a Disrupt 4.0 uh, WhatsApp group on Disrupt 4.0, and so we share a lot of Gyan there on day-to-day basis, which is not generally shared on Meetup group. So meetup group, we try to post the long form knowledge bites. So if you want to join that, I would suggest if you can send me a message. My number was there on the meetup page. Else, Dolly, I'm taking the presentation back so that I can show the contact details.
Right, right. Thank you for bearing with me.
Okay. So this is my number. If you want, you can be part of that Disrupt 4.0 group on WhatsApp, as well as have any questions on this topic. You will be able to send it to me, and I will direct it to Dolly in case you have sent it to me, not to her. We are waiting for any more questions. If not there, then we will close in a few seconds. Dolly, any last statements for as a suggestion or recommendation
So I just
for
wanted
people
to
who are,
know the audience a little better for my this thing, my personal interest as to what kind of profile of audience are there today with us.
oh, sure. So I'm releasing a poll if you would like to, if you would please respond to that. Please respond to the poll that I have opened. Okay, so we have about 75% male here and 25% female.
Okay.
And next
So
one would be there.
that shows the reason for the bias. The talk today
Yeah.
was basically that most of the people who attend such conferences, women in technology, are very poorly represented. Not just because
Right.
there are very few women, but also because that they're hardly kind of spend time in these pursuits and don't get included by either conscious or unconscious reasons
Right.
based on this thing.
So
So
another poll I am opening. If you are from any of the surrounding places in these regions, I would appreciate if you can respond. So we get major audience from these regions. That's why I've given these Delhi, Bombay, Bangalore, Calcutta, or others. If you are from some other region, other parts of the world, just put others. Some people more to respond, please. Some more people to go. Another few seconds. So about 89% people are coming from in or around Bangalore and 11% others. So 11% we can say they are from other part of the world probably.
okay.
Okay, thank you. So WhatsApp group is the Disrupt 4.0 group that we have. Somebody asked question, what is a WhatsApp group? Again, so it is Disrupt 4.0 group on WhatsApp. So if you send a message to this number given on the screen, I'll be able to add you to that group. Any other questions, please? I think no more questions are coming, so we will close the session here. Thanks for attending, and thanks, Dolly, for presenting such an interesting webinar. And we
Thank
look
you.
forward to have future sessions with you. I think we have a few lined up in the future as well.
Thank you, Vishal, for giving me the opportunity, and thank you all the people who were present to patiently hear me out. I look
Thank
forward
you,
to
and have a
future.
nice day and good day.
Thank you.